Hello friends, we are going to learn concept of integration from the unit calculus of IBDP Math AAHL syllabus, and I have taken a problem from IBDP Math AAHL past paper. Now the problem here is A. By using an appropriate substitution, show that integration cos root x dx equals to 2 root x sin root x plus 2 cos root x plus c. The following diagram shows part of the curve y equals to cos root x for x is greater than and equals to 0. The curve intersects the x-axis at x1, x2, x3 and x4. The nth x-intercept of the curve xn is given by xn equals to 2n minus 1 whole square pi square upon 4, where n belongs to z plus. B. Write down a similar expression for x plus 1. The regions bounded by the curve and the x-axis are denoted by R1, R2, R3 as shown on the above diagram. C part. Calculate the area of the region Rn. Give your answer in the form k n pi, where k belongs to z plus. D part. Hence show the area of the regions bounded by the curve and the x-axis R1, R2, R3 form an arithmetic sequence. Now the solution. So we have the equation of curve y equals to cos root x, and we have to show that the integration of cos root x dx. So integration cos root x dx. Now substitute here. Let t equals to root x, t square equals to x, 2t dt equals to dx. So integration 2t cos t dt. Now we will apply by parts here. So 2 integration t cos t dt. So we will assume t equals to u and v dash equals to cos t. Now u dash equals to 1 and v equals to sin t. We know the formula uv dash equals to uv minus integration u dash v. So we will write here 2, u value here is t and v value is sin t, minus integration u dash is 1 and v equals to sin t here. Now further we will simplify. T sin t minus the integration of sin t would be minus cos t plus c. So we can write here 2 root x sin root x plus cos root x plus c. So this is the solution of A part. Now we will proceed to B part. In B part, they have given the expression for x. They have given xn equals to 2n minus 1 whole square into pi square upon 4. Xn equals to 2n minus 1 whole square pi square upon 4, and we are asked to find the value of xn plus 1 equals to, so 2n plus 1 minus 1 whole square pi square upon 4. We will simplify. So 2n plus 2 minus 1, so it would be 2n plus 1 whole square upon 4 into pi square. So this is the answer of B part. Now we will proceed to C part here. The regions bounded by the curve and the x-axis are denoted by R1, R2, R3 as shown on the above diagram. Calculate the area of the region Rn. So area equals to integration cos root x dx, and the limits would be xn to xn plus 1. So we can write here the limits, that is 2n minus 1 whole square pi square by 4, and here 2n plus 1 whole square pi square by 4 and cos root x dx. Now we will use the result of A part. So that is 2 root x sin root x plus cos root x, and here limit 2n plus 1 whole square pi square upon 4, and the lower limit is 2n minus 1 whole square pi square upon 4. Now we will substitute the limits here. 2. So upper limit when you will substitute 2n plus 1 pi by 4 to sine 2n plus 1 pi by 2 plus cos 2n plus 1 pi by 2 minus 2n minus 1 upon 2 sine 2n minus 1 pi by 2 minus cos 2n minus 1 pi by 2. Now here we will simplify. So 2n plus 1 pi by 2, and here the value of sine is the angle given 2n plus 1 pi by 2. So the value would be, the angle value would be odd values here. So sine odd pi by 2, like 3 pi by 2, 5 pi by 2, the value we will be getting, that is minus 1. So the general value we will write here minus 1 power n, and the value of 2n plus 1 pi by 2, the cos value would be 0, minus 2n minus 1 upon 2. Now here 2n minus 1, so that will give you pi by 2 then it will give you 3 pi by 2, 5 pi by 2, again the odd value. So here we will be getting minus 1 raised to the power n plus 1. And again the last term would be plus 0. So 2 minus 1 power n 2n plus 1 upon 2 pi, and here we can write plus minus 1 power n and 2n minus 1 upon 2. So now we will further simplify here. Minus 1 power n upon 2, and here we will be getting 2n pi plus pi plus 2n pi minus pi. So pi and pi get cancelled. We will be getting here 2 and 2 cancel. So we will be getting here 4 and pi. and this value would be modulus, so the answer would be 4n pi. So this is the solution of C part. Now we will proceed to D part. Hence show that the areas of the region are bounded by the curve and the x-axis. R1, R2, R3 form the arithmetic sequence. So in D part, this is the area AN is 4n pi plus 1 would be 4n plus 1 pi is equals to 4n pi plus 4 pi. So the difference D equals to AN plus 1 minus AN would be 4n pi plus 4 pi minus 4n pi. 4n pi would be cancelled and the difference would be 4 pi. So as difference is constant, hence area of regions R1, R2, R3 and so on are in arithmetic sequence. So this is the solution of the given problem. I hope you understood the solution. Please like, share and subscribe this channel.